German-based GAUFF Engineering has been working worldwide in the field of infrastructure planning and urban water management. In 2010, GAUFF Engineering entered into a partnership with Mon Hydro Construction in Mongolia's capital city of Ulaanbaatar. The Selber Valley covers an area of 306 square kilometers. It forms the natural catchment area of the Selber River and is hence vital for discharge. The source of the river Selber is located north of Ulaanbaatar, 1,800 meters above sea level. Many tributaries flow into the river as it runs southwards for 57 kilometers before merging with the river Tuhl. GAUFF Engineering was confronted with many tasks and is eager to master this huge challenge with its knowledge and expertise. Today, 1.2 million people live in Ulaanbaatar. This figure is increasing as more and more people flee from the countryside to the capital city in the hope of a better life. Water demand is continuously rising, but the rate at which new groundwater is being supplied cannot meet the city's growing demand for water. This is due to both climatic and hydrogeological conditions. In the future, the city's main wells will not be able to provide sufficient water. The situation is being worsened by climate change. Rain periods are becoming shorter and precipitation levels are rising. This means that much more water flows faster and causes flood damage. During dry periods, the river Selber dries out. This is also due to the many private wells along the river. The rapid increase in population is causing other problems and is additionally polluting rivers and groundwater. Near-surface groundwater causes frost damage to houses, streets and the infrastructure. What GAUFF engineers now had to do was to use their experience and knowledge to analyze the problems and to come up with solutions as quickly as possible. One of the most important steps was a 3D model that was created based on a satellite survey and an aerial image of the Selber Valley. Geological and hydrogeological surveys were carried out, for example drillings. Engineering focused on the central and east project areas, and wells for measuring stations were upgraded. Water samples were taken and tested for nitrate and E. coli bacteria. These tests were conducted both on site and in labs. In order to simulate rain discharge for the river Selber, the relevant cross-sections of the riverbed were surveyed in addition to the terrestrial measuring. A state-of-the-art laser scan method was used to capture precisely the urban areas threatened by floods. All of the data available and collected was compiled by GAUFF Engineering and examined by its experts. All data was evaluated, sorted and processed. 3D groundwater simulations were carried out. A current land use map and a 1D discharge model were made. Currently possible flood situations were simulated by using different rain scenarios. Based on the results, the Greenland concept was created. A second simulation with flood retention basin was made. A greywater system was additionally developed for an apartment building in a current settlement project. A part of the needed water is taken from the public water network. Normally, wastewater needs to be fed directly into the sewage system. but some wastewater can be processed in the grey water treatment system. It will be cleaned in various process chambers. Ultraviolet light finally irradiates germs. The water can now be reused for certain purposes. The green land concept comprises 3 individual basins arranged as a cascade. When necessary, water can be stored or retained in these basins. This will ensure the safety of the people living in the lower reaches of the river Selbe. The green areas that surround the floodwater retention basins can boost the local climate of the urban areas. Gravitation water vortex power plants are installed at the dam openings and can generate eco-friendly electricity. This electricity is used in the drinking water treatment facilities and to control the basin system. The plant itself can be used as a day trip destination and place of leisure. Another important advantage of this concept is that the water stored in the main basin can be fed through a sand filter system to produce drinking water. This helps to ensure that water is not simply discharged before it can be used, but that it can be used in a sensible manner. Since this project is largely focused on water, a hotel or water congress complex could also be integrated into a greenland facility. The teams from GAUFF Engineering and Mon Hydro Construction are conceived that this sustainable concept can work. In the interest of the capital city and with the support of the Ulaanbaatar government, they are committed to its implementation.